I'm excited to introduce our next panel on the agenda. You know, Texas continues to grow, water demands continue to grow, and there's this constant focus on trying to identify ways to stretch the resource. Produced water in the oil and gas sector has been a focus of that, and that is really one of the it's been a conversation we've been having, and it's the focus of our next panel. And we're excited to have with you Adam Friedman, a partner at the law firm of McElroy, Sullivan, Miller, and Weber, to moderate this panel. I'm going to let Adam introduce our trusty panelists. We're so excited to have you all. Let's just make sure everyone's cameras are on, audio working. Fantastic. Welcome. And Adam, with that, I'm going to turn it over to you.
Thank you, Leah, for helping put this together and coordinating this group, keeping us on track, and also substantively with a very apt title for our panel today, which is Produced Water as Water Supply. That is precisely what we will be talking about. Very important issue statewide, although certainly more pertinent in the Permian area and the Eagle Ford and the Barnett up in the Fort Worth area are some of the heavier oil and gas activity areas. And this topic may sound familiar to some of you. If you attended the summit a couple of years ago, I gave a presentation laying out some of the volumes of water and frankly the vast volumes of water that are associated with this issue, both the produced water that's being disposed of and the amount of groundwater being used for oil and gas activity, and what that meant in terms of an opportunity to really try to reuse some of this and see what we could do as a state and as groundwater districts to facilitate more reuse. And the purpose of today's panel is to revisit some of those issues and some of the opportunities. But importantly, I brought three key experts that know a lot about this subject, and they're going to share their thoughts with you. And those experts are Brian Bohm. He's an environmental sustainability advisor for Apache Corporation. Bridget Scanlon is a senior research scientist for the UT Austin Bureau of Economic Geology. And Trey Gerfers, who's the board chairman of the Presidio County Underground Water Conservation District out in West Texas. So very excited for them to share their thoughts and views on this important issue today, so that it's not just coming from me. They have a lot to share. But before I get to the experts, I'd like to just revisit and give a little bit of an update on the statistics and just sort of set the framework and the background for this issue. And if we flip to the next slide, we'll start looking at some of the volume of water that's being disposed of in Texas. And now this is, what you're seeing here is a bar graph of produced water. Really, it's just all in, wastewater that's being disposed of down commercial disposal wells. They're referred to as SWDs. Many of the districts have probably seen these applications that are filed with the Railroad Commission. This amount of water, you can see a trend back in 2011 all the way to 2018 of increasing disposal volumes, peaking in 2018 with 80.1 billion gallons of wastewater essentially being injected down a disposal well across the state. Now, that fluid includes produced water, which is often referred to as the groundwater that's already in the natural environment, existing in the formations that comes to the surface with hydraulic fracturing or oil production. And it also includes flowback water, which is the injected fluids that operators will use to help with production. So it includes both of those. I'm referring to it, and we'll refer to it as produced water collectively. But that's what makes up the 80.1 billion gallons in 2018, which is, as you see, 248,000 acre feet of water in the year 2018. It does not include non-commercial. Which is that's an important factor, that there's a lot of additional water being disposed of that's not accounted for here. So it's a fairly conservative estimate here for your injected water. And at the same time, if you go to the next slide, while this water is being disposed of down these wells, there is Well, actually, the next slide will just kind of break it down regionally. Waiting for it to pop up here, but the if you look at it on a more of a groundwater district basis, there we go. Like Reeves County, obviously, is at the heart of the Permian activity. In 2016, the Railroad Commission data indicated 17,000 acre-feet of injected wastewater volumes. That number has tripled now in 2019 to 61,000 acre-feet. Same thing in the Permian Basin, although this is just Howard County, you've seen almost a 400% increase in disposed water volume. And so, and Upper Trinity in the Barnett area, that sort of have a leveling off, and the Evergreen and the Eagleford area, you also have seen sort of a slight increase, but not quite the increasing trend in West Texas and the Permian. And this is despite improved technology and improved efforts to reuse this water. So again, it's just important at the beginning that we set out the real opportunity here. And I think it really ties together with the next slide, which shows that while we're disposing of this water, and we're going to talk about all the opportunity and the challenges of reusing that water, but at the same time, you can see here that there are over 30,000 water wells across the state that are being used for supporting oil and gas activity. And perhaps the takeaway, most important takeaway from this slide, is that the increase from 2018 to 2020, where you're seeing almost 1,400 new water wells designated for fracking supply and almost 3,000 new wells designated for rig supply. So it's a trend that continues to increase. Yeah, well, that's okay. You went to the next slide. That's a good cue for me that it's time for me to let the experts take over, because what Bridget, this is, I'll hand it off to you here. But what I was just talking about was a statewide water use. I think you've broken it down maybe by aquifer. So could you talk a little bit about the water use for oil and gas activity, as well as the concerns or the potential impacts that you've been studying over the years?
Thank you, Adam. Yes. So on this slide, on the left-hand side, we show the water supply wells that were drilled in the Permian Basin for supporting hydraulic fracturing. And Adam showed early on the statewide numbers for commercial disposal, 80 billion gallons in 2018, or 250,000 acre feet. So by chance, this number is actually the same number that was used for hydraulic fracturing in the Permian Basin in 2018, 80 billion gallons or 250,000 acre feet. And although that represents a small percentage of the statewide water use, for example, 2% of 2018 statewide water use, locally it's very important. And as we have been discussing in the past few days, Trey has emphasized the scarcity of water in this region because of low rainfall and low recharge rates. So on the left, I'm showing all of the wells that were drilled for rig and frac supply in the Ogallala Aquifer, shown in blue, Edwards Trinity Plateau in green, and the Pecos Valley Aquifer in mustard. And the Ogallala totaled 5,000 wells over the past 10-year period from 2010 to 2019, and the Pecos Valley about 1,000 wells, and the Edwards Trinity about 2,600 wells. On the right-hand side, you can see the time series of wells drilled in each of the aquifers to support hydraulic fracturing. And you can see that the Ogallala in 2019, there was about 1,200 wells drilled in the Ogallala. But we're at the southern edge of the Ogallala, and so they may need to drill a lot of wells because the aquifer is so thin in this region. In most of the other aquifers, it's about 100 to over 200 wells per year in recent years. So that gives you an idea. So we're using a lot of water to support hydraulic fracturing and drilling a lot of wells. Next
Bridget,
slide, please.
Oh, yeah,
go ahead.
Did you have a statistic of about how much water gets used for a hydraulic fracturing well?
Oh, yes. So the median value in the Permian Basin in 2019 was 18 million gallons per well, but there's a lot of variability, and it ranges, the 5th and 95th percentiles range from 9 to 36 million gallons per well, and 36 million gallons corresponds to about 40 Olympic swimming pools. So on this slide, then there is a lot of concern about competition among different water sectors. And in the Permian Basin, the water use for hydraulic fracturing represents about 30% of the water use in other sectors. On the left-hand side, we show the land use, and the blue area shows where there's the dense irrigation occurring. And on the right-hand side, then we show the hydraulic fracturing wells over the past 10 years. And you can see that most intensive hydraulic fracturing occurs south of where we have intensive irrigation. So the two are not directly co-located. And so there's not huge competition then for the same water source. And on the right-hand side, then the colors of the counties then reflect the total water use over the 10-year period. And you can see the high red colors in Martin and Midland counties are reflecting high water use, and also in Reeves County. Next slide, unless you have any questions, Adam.
Nope, doing great.
So one of the issues with water use, then we don't have any reporting on how much water, produced water, is recycled for hydraulic fracturing in the state. And and we'll hear more from Brian Bohm from Apache about this shortly. But the more groundwater we use, then that can impact the surface water. And here in this graph, I'm showing the springs in the Delaware Basin. And the red springs are flowing springs, mustard are intermittent, and white or dry, and blue, we're not sure. So one of the biggest springs in the area is the St. Solomon Springs, and in Balmorhea State Park, and it's very important to maintain flow in that. So that reflects groundwater discharge. So if there's a lot of groundwater depletion from the source of the spring, that would impact the spring flow. So Apache has supported a study by the Bureau of Economic Geology to evaluate, to pinpoint the source of water from the regional flow system and the more local flow system that we've been conducting over the past couple of years. So it's more critical in the Delaware Basin to manage groundwater use because it is connected to surface water. Groundwater discharges to these springs and also to the Pecos River. In the Midland Basin to the east, it is not connected to surface water because of previous irrigation depletion. And last slide for me, next please.
I think that your last slide will come a little bit later, Bridget, when we talk.
Okay, sorry. Yeah.
But before we move on to this slide, if we could go back to the last slide on the springs, you have in parentheses, what is the water source? Is that an, what do you mean by that? Is that a suggestion that more exploration or more understanding of where these springs are being fed from would be prudent?
Correct. We really need to understand the source of the water, which is not an easy task because we need to protect those areas and make sure that we don't overexploit the source, the groundwater in the source regions of the springs. And so that requires detailed studies of chemistry and flow physics of the flow system, that sort of thing. And so Brad Wooliver and JP Nico and others are doing a lot of work on this topic.
And in addition to the impacts or potential impacts to springs from the use of the groundwaters, have you studied or looked into, or what is your understanding of the potential impacts to the aquifers themselves in terms of drawdown or sustainability from the groundwater being used to support the oil and gas activity? I know I've previously referenced a study that you helped write in the Eagle Ford area, which was a confined aquifer, which talked about some potential for significant drawdown. What is the latest on that sort of thought?
So we have examined the groundwater level monitoring data that the Texas Water Development Board collates and monitors. And we haven't seen much impact of water use from hydraulic fracturing, but it may be an artifact of the low density of the monitoring network, because the state groundwater monitoring network was not specifically designed to assess the impacts of hydraulic fracturing. So in many of these unconfined aquifers, unlike the Eagle Ford area, the impact of pumping would be highly localized, and so that would require a very dense network to see those impacts. So I think we should have, increase the density of the monitoring network to assess the impacts of pumping for hydraulic fracturing.
So it sounds like there's a little bit of an unknown as to what sort of the real-time impacts may be from the water use in, say, the Permian. Is that fair characterization?
Right. Well, we're not seeing any regional impacts, but that may be partly because many of the aquifers are unconfined, and we wouldn't expect to find regional impacts in unconfined systems. Yeah, so we really don't know the full extent.
Well, Trey, I'd like to have you interject here a little bit. I mean, given that you're a member of a groundwater district out west, I mean, is that something that you've kind of kept your eye on, the need for more data or monitoring? I think you're on mute, Trey.
Colleagues. Can you hear me?
There we go.
There we go. Can y'all hear me okay?
Yeah.
Yeah, so I think definitely among all my colleagues out here in far west Texas, we're very concerned about just not knowing what we don't know. And many districts are pretty hamstrung by a lack of funding to be able to afford the kinds of monitoring that would be necessary, a denser monitoring network, both for quantity and quality. And because we are in a very, very rain scarce region, 8 to 14 inches a year. And so even though maybe the percentage of groundwater that's used for hydraulic fracturing statewide may be something on the order of 2 or 3%, the localized impacts are going to be much greater in a region that just doesn't have as much water and doesn't have as much rain. So that's what we're really concerned about and what we're really working on. Some places like Middle Pecos, they've got an incredible monitoring network, but then places like Brewster, Presidio, Reeves really don't have much. I mean, we've got some TWDB data. Presidio's just started some monitoring. We're in a very nascent stage, but we've got a lot of catch up to do as far as getting good baseline data.
And this may be sort of a silly question, but is something that the groundwater districts might be interested in, would seeing reuse of the produced water if the end result of that is to free up fresh water or groundwater for repurposing elsewhere?
Definitely, definitely. I mean, I think we see our role mainly as monitoring. I mean, we've got one operator in Presidio County, and we've gotten them to agree to allow us to, that they're reporting how much water they're using, and we're tracking that. And so, but any solution to reusing this water, especially if it can just be reused for fracking over and over again, I think is smart. And I think any groundwater district would do, whatever's necessary to try to expedite that and facilitate that.
And we'll try to cover maybe some of the ideas later in the panel about how we as a state can help districts do that when we talk about a path forward. But I'd like to bring Brian in here. It sounds like from Bridget and Trey, there really is a little bit of an unknown as to the impacts that may be happening or in the future. But from what I understand, Apache has gone ahead and really taken great efforts to try to reuse its own produced water. Can you just kind of walk us through a little bit? And I think if we go to the next slide, just walk us through, what Apache has really strived to do the last few years, and frankly, why? What was the catalyst or impetus for taking those measures voluntarily, frankly?
Sure, there's a combined effort. You know, there's certainly an ESG or a sustainability mandate that kind of is behind it from a corporate level, but the reality is that we see the produced water as a waste resource that we can reuse and recycle that provides us with the economic benefit of not having to purchase water, not having to dispose of water. You know, so there's a cost savings component, but there's also the fact that the best use for our produced water is for us to recycle it and reuse it. So that's what we push and strive to do. So, you know, the graph here kind of shows the last five reported years from our sustainability report, showing how we've continued to increase the amount of produced water we recycle and tried to reduce the amount of fresh water we use, you know, because we try not to compete with the local areas. Now, you're always going to have a component of freshwater usage. We're an international company, so we have areas where we operate where it's easier to use fresh water. But two, the way we move water through temporary pipelines a lot of times requires that we do pressure testing on that pipeline to make sure it's not leaking. And then when we do that with fresh water because we don't want to spill fresh water on the surface. And at the same time, we flush those lines at the end with fresh water to make sure that when we do come and break those lines, we're not dumping produced water on the ground. So, I mean, it's an environmental impact that we're trying to prevent when we do use that fresh water.
Well, can you tell us what is the picture that we're looking here? Describe some of the numbers that Apache has sort of achieved over the last couple of years here.
Sure. So we've reduced now to, at the corporate level, from, you know, over the past, you know, between 14 and 18, from about 11%. We've cut that in half of our freshwater usage. We're down to about 5%. The growth that you do see is in both produced water recycling, which has grown slightly over time, but the other growth you see is brackish water usage. We've actually started to target a lot more of the aquifer systems that have a little higher salt content, so we're drilling a little bit deeper water wells. So for instance, in Reeves County, we target the Rustler aquifer and try to target that to get more growth in terms of our water usage and sourcing from brackish water sources instead of competing with fresh water.
Are those water wells, or are those used for kind of a main source for hydraulic fracturing, or is that source of sort of blend water to help with other uses, other types of water? Or both?
So it's both. Most of the time it's used for we have a volume. So when we drill a well, we've got to drill through a freshwater aquifer or through a brackish water aquifer. We're going to use brackish water to do that. The way we operate is we don't tend to blend our produced water with fresh water just because we don't need to. So we'll pump fresh water at the beginning of a completion to pressure test our lines, and then we'll start our completions with that water. We'll start pumping brackish water or produced water after that, and then at the end we'll flush our lines with fresh water. So we never really truly blend, but we've just developed industry chemicals now that are more compatible with a brackish water. You know, we can use an 80,000 TDS water, 100,000 TDS water. So we can work with produced water, and we have just as adequate and satisfactory results in terms of our well production from those as we do from using fresh water. And that's kind of been a big transition that's happened more in the last 5 or so years, maybe 10 years, is that the chemistry from the chemical suppliers has become developed less for freshwater usage and more now for brackish or produced water usage. 2020 is going to be a different year, though. I mean, we've got a transition now without the capital and the well development that we've seen in the Permian, with the rigs moving out and the completions falling off. You're probably going to see a lot more disposal in 2020 than you would have seen in 2019.
And you know, you mentioned about the applicability of lower quality water for operations. But before we kind of dive into that a little bit, on the next slide, I'd really like to have you sort of walk through what kind of infrastructure Apache was putting in place or had in place to facilitate its sort of robust recycling program. Just tell us a little bit about, you know, what we're looking at here and the pipeline infrastructure, and then we'll talk about if that's applicability elsewhere to other operators or third parties, and whether this is economical. At least it was at one time.
Sure. So this is the yellow is basically the Alpine High, Apache's Alpine High acreage footprint at one point in time. I believe this would probably be late 2018. And because we had relatively continuous acreage, we were able to install in a time of good commodity prices our own water infrastructure, which allowed us to do the one thing that makes recycling and reusing produced water feasible, and that's taking water from where you're producing it and moving it to where you need it to do completions. You know, so for us, we had continuous acreage. We were able to get long pipelines in, and we were able to pump water to where we needed it. When you go into a situation where you don't have a lot of continuous acreage, or you've got kind of a checkerboard more with multiple operators, this is less feasible for an operator to put in, but then the third-party water infrastructure and the third-party water midstream companies become a higher priority. So in this instance, we had about 10 million barrels of produced water storage, which really helped us to facilitate a 95% recycling program over 2.5 years. You know, and this was a greenfield development, which allowed us to do all of this.
And so you mentioned the midstream infrastructure and third parties. Is this type of infrastructure and operation something that other operators could look into doing? Is it? I mean, obviously economics play a role. Can you speak to that a little bit?
I think moving forward, you're going to see the economics transition. You know, when commodity prices were great and we had available capital, I could get a water infrastructure project to compete with the capital the company had to drill another well. Going forward, as we move into a free cash flow focused model, you're going to probably see less funds available for operators to do projects like this, and them looking to turn to third-party water midstream companies whose business is to build water infrastructure and move water from operator to operator.
And I'll talk a little bit about the regulatory framework for those third parties here in a minute. But aside from the permitting processes and the economics, you alluded to the quality of water maybe being less of an issue now. Can you speak to that from a potential third party recycler who helps move the water or treat the water for reuse? How does the quality of water come into play before we get into the regulatory side of things?
So one of the things we're still fighting with in the industry is trying to identify what is a suitable quality for reuse. You know, for me, internal to my company, I can please my chemical program because I'm using one chemistry and I'm recycling within the company. When you go to a third party where you're taking water from multiple operators or trying to send it back out to multiple operators, each one of those operators is likely to have a slightly different water chemistry concern, or maybe a different need based on the chemicals they're using. So one may need you to remove iron. Another one may just be concerned with, you know, organics, you know, making sure there's no free oil in there. And you know, so, and really it's all, if we can get to a clean salt brine, almost every operator will be happy. But it's that incremental of trying to treat to everybody's spec, where the third parties are right now having a lot of difficulty getting off the ground or implementing this further. But I don't think it'll be too long and the industry will come together and try to identify a common water reuse spec.
And sorry if you mentioned this, but the TDS levels, is that something that is prohibitive of reuse? When you get the high TDS levels that, you know, they often can be orders of magnitude above sea level, is that still an issue? I understand the chemistry makeup may be different, desired by various operators, but what about the TDS levels in particular?
So an 80,000 to say 120,000 clean TDS brine, you know, I mean, it'll have 120,000 TDS, but if it's a clean brine where your primary constituents are just sodium and chloride, it's easily reusable water. It's some of the more isolated chemicals is where a lot of operators struggle, because iron interferes with certain things. Certain other divalent cations can interfere with a cross-link gel, you know, and things that we try to do to just make sure we're carrying the sand to the places we want it to go.
And Bridget and Trey, I'll just ask if there's anything you'd like to add right now. I'm going to just go over a little bit about the regulatory framework for the commercial and non-commercial recycling at the Railroad Commission. But anything we've talked about, the technical treatment or requirements of the produced water, the treated water, anything to weigh in there?
I guess I would just add, I mean, I think as Brian mentioned, you know, the chemical requirements have changed over time. Initially, everybody was very concerned about how much water they were using for hydraulic fracturing, and then they switched from slick water fracs to gels, and that reduced the volume of water, but it had more chemical restrictions on the type of water. But then I think they switched back to more slick water, and that opened up the chemistry of the produced water that could be used. So I think that's kind of been the evolution of the system. And you know, companies like Pioneer and others have built a lot of pipeline. We need, in order to have the produced water supplies meet the hydraulic fracturing demands, we need storage and transport. And so pits and tanks to store the produced water, and then pipelines. And so as that infrastructure expands, then I think reuse will increase.
Yeah, and you know, speaking of the infrastructure that's required, the storage, you know, most of that is permitted by the Railroad Commission, and in 2013, they restructured their rules to allow for what they call non-commercial recycling without a permit. It's really was an effort to try to increase the reuse. They created a separate permitting process for commercial recyclers, those who are recycling for the primary purpose of making an economic benefit. And I think that that's really been capitalized on, and I think that's helped increase the recycling. But there are still only, as far as I know, 2 permitted commercial recycling facilities in the entire state. I'm not sure if either are operable, and it's possible there have been subsequent permits issued since I last checked, but still not a robust use of that mechanism, the third-party commercial recycling, Brian, that you sort of referenced. But that permitting process does exist. It's, you know, no permitting process is without some obstacles or hurdles, but it's relatively painless. It can be done, and it just hasn't been utilized. And I just wonder, Brian, you know, the Railroad Commission took that effort to do that, and the legislature has taken some efforts to try to help answer questions about ownership of that produced water. And I'll get to that maybe in a little bit. But any thoughts on the holdup or the lack of permitting or the lack of pursuit of those permits for third-party commercial recyclers?
You know, I still think it comes down to a lot to trying to figure out what quality you need to deliver to your client. You know, so me as an operator, I may have one water spec and another operator may have another. If you're trying to treat to match everybody's spec, the cost increases significantly. That's one of the bigger hurdles. There's other hurdles. I mean, there's still, as an operator, I think there's a lot of belief that what the regulations on produced water have done is released us from liability associated with the disposal of the waste. There's still, I think, a lot of us that question whether or not ownership and who owns produced water has been answered yet. And I think that may get to what, you know, some other questions that need to be answered.
Yeah, and just since you mentioned that, you know, the legislature last session, and I'll have a slide later that puts it up, the House bill that was eventually adopted, but it did seek to clarify the ownership of that water to help facilitate reuse and recycling. And I guess what I'm hearing, it sounds like there may still be a little bit of uncertainty from an operator's perspective. Is that fair?
Yeah, I think as an operator, we certainly, I mean, we've got to operate on our surface owners, right? So we're not, you know, we're not gonna, and honestly, for us personally, we're not in the business to make money off the water. We're just trying to reduce our lease operating expense on the disposal of that water. So if that means that we can send it to a third party who can treat it and help others reuse it, we're more than happy to do that. but there's a landowner out there that has to have that question answered as to whether or not they should be compensated for that. And right now, there's just no way to track molecule by molecule water to try to compensate those landowners.
And you mentioned the landowners. Is that another issue that comes up when you're trying to establish or build the infrastructure, the midstream or the storage of having a recycling operation move forward?
Absolutely. I mean, we've got to negotiate, whether it's us or a third party midstream company, we've got to negotiate an agreement to move water across the surface. Commodity pipelines have, eminent domain rights in some cases, so they're able to negotiate to a different approach. Usually water is a completely different argument. I shouldn't say argument, but a completely different negotiation. My land guys would probably get mad at me for saying it's an argument, but I mean, I think it's certainly a contested discussion where, water is something that's almost always separated and treated differently than the rest of the negotiations when it comes to pipeline negotiation.
Bridget, any thoughts on ways of addressing the landowners' concerns? Is there a precedent that could be set? Are there bigger landowners to work with that might be able to set the standard so that we might facilitate more reuse and not be held up by the negotiations of a surface estate?
Well, I think University Lands owns a lot of acreage out in the Permian, and a lot of operators look to them to provide guidance and their stewardship. They could be role models for others and provide a template of some of the processes that are required. So I think that represents a great opportunity to develop procedures and practices that would be beneficial to the environment.
Well, we've sort of touched on some of the challenges, and there are certainly no short list. I think the goal is to try to overcome these challenges, whether it be from a district perspective or the legislature or an agency perspective. But can we talk about, and Bridget, maybe we'll start with your slide, the next slide, some of the opportunities if we can navigate these hurdles, these challenges, what does that mean for the water supply regionally of some of these areas if we can do that?
So in this slide, I'm showing the volumes of water from 2018, produced water and hydraulic fracturing water and irrigation for each of the 19 counties where there's most intensive hydraulic fracturing in the Permian Basin. And the volumes are shown in billion gallons, and it represents 2018 data. And the gray bars are the produced water. The blue is the hydraulic fracturing water use in 2018, and the green is the irrigation water use. So you can see in most counties, and this is a log scale, you can see in most counties that the produced water volumes and the frac water volumes are similar. So that suggests that there's a real opportunity to reuse the produced water to support hydraulic fracturing. Of course, as Brian will indicate, the logistics are still an issue, timing with the produced water supplies and frac water demands and drilling and all of that sort of thing. But at this scale, it looks like there's a lot of opportunity to reuse the produced water for fracking. And as Brian explained, the water quality requirements for that are minimal, clean brine, and so minimal treatment requirement. And that would, if we did that, then we could save all that water in the aquifer for other sectors. In 2018, the water use for hydraulic fracturing represented about 30% of the water use in the basin. So we could leave that in the aquifer, or it could be available for other sectors in the future. So I think that's what the main point of this slide.
And can you just tell us about the unit of measurement here? This is in billions of gallons per year? Right,
and it represents 2018. So as I mentioned earlier, in 2018, we used in the Permian Basin, the hydraulic fracturing volume totaled about 80 billion gallons, or 250,000 acre feet approximately. And so this is by county, then shows what we used in each county. And this is the produced water volume in each of those counties for that year, and the irrigation demand.
And so I think it's pretty obvious that 100% reuse of the gray line is unlikely to capture and reuse all of it. But at least conceptually, what this would show is wherever the blue line of which is water used by hydraulic fracturing in that county is shorter than the gray line, you might be able to really cut in, if not completely address the water demands for the oil and gas activity in these counties. Is that another way of interpreting this chart?
Yes, definitely. And of course, we need to consider the trade-offs. I mean, if you are storing and transporting produced water, that's a lot different than storing and transporting fresh water. So there should be increased monitoring, as Trey mentioned earlier, of water quality issues, so that we make sure that we don't have more spills and leaks of produced water, which could be an issue. So we have to manage those things and make sure that it is safe.
Well, Trey, this sort of demonstrates what I asked earlier about kind of the no-brainer question about what a groundwater district might like to see. I mean, does this sort of capture your sentiment earlier about that freeing up water for other uses?
Yes, and I'm really struck by how, the fresh water and the produced water in this graph kind of almost is exactly mirrored in many of these counties. And so, I mean, if we can get to a point where a lot of those freshwater needs are being met with produced water, then obviously that's going to take a lot of the pressure off of our aquifers. But it also introduces other challenges like, the potential for contamination. How are you going to transport these things? And so, but I'm struck by how, the solution is potentially there, but you have so many other things that you have to worry about, all the infrastructure issues that Brian talked about, all of the surface rights that have to be negotiated. I mean, all of these different hurdles that have to be overcome. So you really need everybody working together and everybody focused on the same goal or goals. And we're kind of starting to get there, but I mean, just in preparing for this panel, I'm just struck by how big of a challenge this is. Even if we really want to do it, there's a lot of things that we've got to overcome.
Are there some things, I mean, if the districts wanted to work together or try to work with the Water Development Board, I mean, is that something that someone from a district's perspective might be interested in or trying to facilitate?
Definitely. I think we definitely need more monitoring, like I talked about. We also have a little bit of a regulatory catch up to play. I mean, we talked about in one of our warm-up sessions about that export permit that Culberson dealt with a few years back, where they were looking at 6,000 acre feet leaving their district and no real ability to gauge impacts on, say, San Solomon Springs in the next county over. We as a region need to start working together to get interlocal agreements where we can take those sorts of impacts into consideration when issuing permits, because this recycling infrastructure, it just isn't there yet, and it's going to be a while before we get there. And so districts need to be able to look at impacts outside of their jurisdictions. I think Brian pointed out during one of our talks leading up to this that, the political lines are drawn for political reasons, but the aquifers really don't obey those. And so we need to be able to look at that as well. But I'm excited about this opportunity. I'm just really bowled over by how complex it is.
And one of the things of the monitoring and an opportunity for that, obviously funding is always an issue. I mean, is that something that maybe there are statewide resources that, if could be made available, something that you could coordinate, or not you, but districts could coordinate The legislature is working on various ways of increasing reuse. Is funding a pretty important mechanism that the districts might like to see talked about?
And yes, and it has been. I mean, I've been in touch with Senator Rodriguez, our state senator, and he spoke at the Groundwater Summit, I guess it was 2 years ago, and was talking about maybe ways that the state could aid groundwater districts like mine, Presidio County. I mean, in Marfa, our budget is $44,000 a year, so I mean, we really need funding so that we can have, real monitoring that can meet this enormous challenge. And I know my neighbors, to the east and the west could probably use more funding as well. So, and then just the dedication of staff that are working really hard and volunteers like myself that are working really hard to figure out, what can districts do to safeguard the resources and to facilitate solutions like these.
And the monitoring would frankly frame the issue to the seriousness of it. I mean, we would know, whether it's something that is urgent or that maybe there's time to sort of work through this issue, right?
Yes, absolutely. But right now we're in many parts of West Texas, we're flying kind of blind.
So Adam, I just want to interject briefly and let you know we're looking at about 10 minutes. So if you wanted to reserve any time for audience questions, which we have had a number come in, just a heads up on that.
Well, I mean, we've got a few more minutes of material. I had budgeted, I think it's 7 minutes or so. Let me just get through quickly, at least the next 2 slides, because I think they're important. And I'll just go quickly and reserve more time for questions if I can. But basically, I just piggybacking off what Trey was just talking about possible solutions from a legislature or regulatory perspective. Last session, the legislature did change the Texas Natural Resources Code to try to clarify that the ownership of the produced water, obviously there may still be some uncertainty, but some of the more interesting things, the House actually passed a bill that would have provided a franchise tax credit if, depending on how high the TDS the source water was, if you were able to treat that to usable fresh water, then you were actually eligible for a franchise tax credit. And it creative, and I think the right type of thinking that's really going to facilitate and bring this issue forward. Did not pass the Senate, I guess, but I think we'll probably see something similar revisit next session. There was also an oil and gas production tax credit available if you were to treat the produced water for an ASR project. That was a proposed bill, did not get out of the House, stayed in committee. Again, another creative type of thinking that really might help neutralize some of the economics of this recycling programs. Brian, actually, why don't I let you interject real quick there? Those are helpful and creative thinking, but how does that jive with this idea that the treatment really isn't the primary hurdle anymore for reusing this water?
Well, again, it's at this point in time for me, this is looking to move this water, our oil and gas water, into some other resource, because we don't need it to be treated for freshwater use for reuse within our own industry. And to me, reuse within the oil and gas industry is still probably the most beneficial use that you can get out of produced water. There's a lot of questions about what I will call emerging contaminants of concern, or emerging, some of the unknowns in what's in our produced water that are always going to have a fear, that maybe it shouldn't be used for fresh water. And until some of those answers are answered, I agree. But I think in terms of reuse for within the industry, we don't need to go to a freshwater standard.
So it's interesting. I mean, it's good initiative from the legislature, but maybe in this session, there will be some other creative ideas that maybe that are tailored towards reuse in the oil and gas industry. It'll be exciting to see what comes out. But you just mentioned a great segue into our last slide. I'll skip over what some of the other states are doing, but other states are taking action, trying to address this issue. But you hit on a major point that we certainly don't want to leave the audience without. And Bridget, if you want to talk very briefly what this slide tells us, but talk to us about the capability or the safety or where we are about reusing produced water elsewhere outside of the oil and gas industry.
So I think to reiterate what Brian just said, the lowest hanging fruit is to reuse the produced water for hydraulic fracturing, which is shown in the lower left quadrant here with a tick mark. You know, we can just minimally treat it to a clean brine and directly reuse it for hydraulic fracturing if we can get supplies to meet demands. So we need to maximize that before I think we consider other potential uses of produced water. There's a lot of interest in treating produced water for other purposes, industrial purposes, but there's not a big industrial demand, for example, in the Permian that would need the produced water. There's also, because irrigation is the highest water demand, there's a lot of interest in treating produced water to a point where you could use it for irrigation. And but there's also concerns. I mean, maybe for non-food crops, for cotton, a lot of people bring up California, but California's produced water is very high quality, and also coal bed methane produced water is very high quality. So we need to be aware of what type of produced water you're talking about. And I think we need to do a lot more research, as Brian mentioned, to understand the constituents in produced water, and groups like EDF and others are working diligently on this, and the New Mexico Produced Water Research Consortium is doing a lot of work on treatment options and the reliability of treated produced water, and make sure that they get out all of the potential contaminants. But I think there's a lot of research that needs to be done before we can consider beneficially using produced water outside of oil and gas.
And Bridget, I think that's the perfect summation. Is it's not foreclosed that we might be able to use this water for other purposes in the future, but EDF and others are doing a good job of making sure that we're doing the right studying. But in the meantime, the low-hanging fruit is right before us, and to reuse this as much as possible in the oil field. And with that, Leah, I think we've concluded, and may not be as much time as hoped for questions, but we're here.
I have to laugh, Bridget, you kind of summed up and answered two of the questions we had come in the last comments you made. So I won't dwell on those and come back to them unless we have the time. But we did have some others come in, and Bridget, maybe this one, because you work with a lot of data, want to take on first. In terms of estimating water use for rig, frac, and industrial use, do you think that the reporting we're seeing right now to TDLR is accurate?
The TDLR gets data on the wells that are drilled for rig, frac, and industrial wells. So I don't really know. I've heard some people say maybe it's not totally accurate, but I haven't delved into it further. We take those numbers at face value, but I think some of the GCDs may be more in tune with that and may have more information. So probably should follow up with them in the future about the reliability of those numbers.
From an operator's perspective, I know there's wells that we've drilled for rig supply that still show up as a rig supply that are either turned over to a landowner or haven't been used for rig supply for years. So, you know, there's certainly a little bit of a ghosting to that data, I think.
So yeah, Brian, another question came up that kind of goes to Apache, and maybe I'll ask both of these questions at once, just in the interest of time. How do we get other companies to follow the example that Apache is setting with its work into really reuse and recycle this water? And how do you, if at all, coordinate with your local GCDs?
So the first part, I think you'll see a lot of the larger operators, the Apaches, the pioneers that are already kind of stepping into this role, trying to reuse and recycle as much as possible. And a lot of it was because we had the capital available at the time when prices were good to build the infrastructure to do the recycling. I think as we get to a point where we start to see a more common treatment that'll facilitate third party, that's where you'll start to see a lot of the smaller or mid-sized operators become more involved in the recycling. It's a matter of the resources available to you. You know, there's operators out there that can afford to drill and complete wells, but they don't have the money to build the infrastructure. You know, so they got to rely on a third party to do that. And right now, economically, third party disposal is a cheaper option in the Permian Basin. On the second part, we work a lot with Reeves County GCD, Greg Perrin. I've tried to get as much data as I can to him. I mean, that's primarily the area I work in, but I know as a company, we try to make sure that we're sharing data with the Water Development Board, with the Railroad Commission. You know, when we drill new deep Rustler Aquifer wells, I'm supplying log and well data to the Railroad Commission so that they know what is the depth of fresh water. So that way, when they do their groundwater level or their groundwater letters for other operators, that they have an idea of what the actual depth is, and we can get a little more accurate data when we sort of set our surface casing and we're trying to protect those freshwater resources.
Thanks, Brian. And that actually leads into a question, probably, Trey, that you would be best positioned to answer as the GCD person on the panel. And kind of, could you speak to the roles that relationships play with the oil and gas companies when it comes to this kind of development coming into a district?
Absolutely. I mean, all of my colleagues across the region would definitely concur that, I mean, it's all about talking, communicating, having an open mind, open door. And really, I mean, when we had Helios come in to Presidio County, I mean, they were unaware of some of our rules and some of the things that they needed to do. And, you know, maybe a less prudent approach would have been to kind of go in for the kill, but we just decided, look, we've just got to give them the benefit of the doubt. Let's open up a channel of communication. And so as a GCD, I think the best approach is to just have your door open and be ready to communicate with any operator who has really any ideas for how they're going to set up business in your district.
Thank you. And then, you know, I've gotten a number of questions on the same topic, and Brian, I think probably you're best positioned to speak to it. And you alluded to it, I think, in your comments, dealing with some of the issues with the surface land owner and how that is a potential impediment when it comes to infrastructure and some of the other efforts to reuse and recycle. And maybe you just want to, if you could just reiterate or expand on some of those comments.
So obviously for us as an operator, it's key that we have a great relationship with our landowners, because especially with landowners who don't have minerals, because the reality is their interest is that surface, and that surface is always going to be a priority over what's going on in the subsurface. So whether it's us, whether it's a third party, you've got to be able to develop a relationship with the surface owners and be able to ensure them that what you're doing is the best sustainable operation for the environment, and you're trying to protect not only their resource but all resources. You know, and as a responsible operator, I think everybody treats it that way. And we realize that landowners need to be compensated for their resource, you know, whether it's just us using it or whether it's actually the water. So it's just a negotiation and trying to make sure that you can establish that relationship as best you can.
Now I'm unmuted. It's 2 o'clock on the button, just right on the nose. So I want to thank you all for a really, really informative discussion on a complicated issue. We got way more questions than there were time to handle. Some of them were very data specific, and so I may pass those along to the appropriate person on the panel and see that those get answers. But with that, thanks again. Appreciate all of you being a part of the summit.